Hello everyone. In today's video, we'll continue building our AI system so that it can move backward and return to its correct path after hitting an obstacle on the track or when it finds its way blocked, just like what you see right now. If you haven't watched the previous video, it's better to do so first. So, as usual, today's video will be simple and creative. Let's begin. Let's go to the AI car. I'll change the car's model to make it more distinguishable. We already created several cars in the first part of the series, so I'll use one of them here. Next, we'll create two new custom events. The first one will be check forward, and the second move backward. We'll start with check forward. We'll use a line trace, starting from the actor location, but we'll adjust the Z value slightly. For the end, we'll use the forward vector multiplied by a value, which we'll make into a variable. I'll make it a variable because we might want to modify it later. After that, we'll create a new variable and name it isHitting. Once we confirm that a collision has occurred, we'll set this variable. Now, after finishing this part, let's move to move backward. What we'll do here is quite simple. We'll check if there's any obstacle in front of the car. If there is, we'll make it go backward, but with a few conditions. First, the speed must be less than 5 because we don't want the car to move backward instead of overtaking when it's moving fast. Then we'll add a 1-second delay because we need to ensure the car is really stopped or unable to move forward. After that, if there's still a collision, we'll make it move backward using a new variable named goBack. If the speed isn't within the required range, we cancel the backward motion. Finally, we make sure to call check forward in the event tick. That was the logic part. Now, to make it actually work, let's move here. First, we'll check the goBack variable. If it's enabled, we want the car to move backward. So we stop its forward movement by setting throttle input to 0 and set brake input to 0.5. Setting it higher than 0.5 will increase the strength of the reverse motion. I'll also add an extra condition with a variable named reset wheel steering when move backward. This is simply an optional setting. If you enable it, the car will move backward perfectly straight, without keeping the wheel rotation from before the collision. Leaving it disabled will make the car move backward while maintaining the previous steering direction. My advice is to keep it disabled, but I added it because we'll need it later when we create unique personalities for each AI car. After finishing this part, it's important to reset everything here using do once. There's just one more small adjustment left. Here, where we built the logic for slowing down during turns, we'll add a goBack condition to prevent any potential errors. All right, now that we're done, let's test it. We'll first need to add an obstacle in front of the car to test the behavior. So I'll place this wall. Let's try it. It's not moving backward. Wait a second. Let's see what's wrong. Ah, yes. I forgot to place this inside the event tick. Let's try again. It moves backward just a little before it fully finishes reversing. I think I know the problem. It's because I used absolute speed to get the car's speed, which always returns a positive value. To fix this, I'll add a select float and connect it here. I'll name it Get the Real Speed. Now, let's go back and make this condition true. Good. Now when it hits the wall, it reverses every time after each collision. I'll just change one thing. I'll replace the line trace with the sphere trace to widen its detection range. And I'll also slightly reduce its length and height. Perfect. We've achieved our goal. You might say this seems useless for now, but that's because we haven't yet built the overtaking system, which we'll create in the next video. In that one, the AI will move backward and then overtake the obstacle when it encounters something like this. Whether it's a wall or another car that's stopped or moving slowly. So, you can think of this as part 1, and the next video will be part 2. Don't forget to subscribe and thank you for watching.